assistant professor in Tulsiram College of Engineering, Nagpur. Now here I am going to deliver video lecture on the topic of law of thermodynamics. Now earlier we have discussed the first law of thermodynamics. Now we will here discuss the second law of thermodynamics. We will start from the basics, that is limitations of first law of thermodynamics. Why there is a need of implementation of second law of thermodynamics? Because due to the limitations of thermodynamics, first law of thermodynamics. As you know that the first law of thermodynamics tells that heat will transfer from higher temperature to lower temperature, and also it gives the idea about the cyclic integral of heat transfer is equal to the cyclic integral of work done. So and hence the heat is equal to the internal energy plus work done. So here heat flows from higher temperature to lower temperature in the first law of thermodynamics states, but never from the lower temperature to the higher temperature, because a body at lower temperature is stable. So stable body will not go to the excited state. So this is a nature phenomena. Body at excited state will comes down to the lower state. Similarly, a body at higher temperature means the molecules are in the atoms are in the excited state at higher temperature. So it will be get stable by at lower temperature. So the heat will transfer from hotter side to the colder side of the heat. From this diagram, you can see that the hotter side, the temperature flows to the colder side. Means the temperature flow from higher temperature to the lower temperature, but never from colder to hotter state, as I discussed. So from the first law of thermodynamics, heat loss and heat gain must be equal in both the process. This heat will be balanced, whether it is rejected or added heat, but the net heat balance will be equal. So according to the first law, it is assumed that energy transfer can take place either in direction, but it does not give the specific direction of heat. In which direction the heat flow, the first law of thermodynamics does not give any idea about the direction of heat flow. So it is not specify the direction of the energy transfer. Okay. So now this is the practical example where we see that the heat is totally not completely converted into the work, but there is a part of heat is rejected. In practical, there is a part of heat is rejected or loose. For example, in an internal combustion engine, all heat are generated by the combustion of fuel and it will work to convert it to work. Now, but the portion of input heat is to be rejected in the form of exhaust gases or cooling water. So you can say that the heat, total heat cannot be completely converted into work, but there is some heat rejected in the form of exhaust gases or cooling air, water, or this from this diagram it will be clear. Similarly, in a power plant, all heat are generated by the combustion of fuel, which is used to convert the heat energy into the work. But similarly, there a part of input heat is rejected in the condenser. Here, this is the condenser. Condenser has a work to cool down the temperature or reject the heat. So some input heat will be rejected in the condenser to cool down the temperature of the steam and make it convert into water, which is will further transferred in the feed pump. Then it will be go to the feed water. Now here the first law interpretation. You can say the first law states the work can be converted into heat and heat into work. Means heat and work are convertible as per the law of first law. And the first law doesn't give any specific possibility direction of the energy. And first law not sufficient. Only first law is not sufficient. but whether a system will or not undergo a particular change. Similarly, first law of thermodynamics is necessary condition but not the sufficient condition for the process to take place. Now, there is an implementation of second law after the limitation of first law. There is a need of second law which states that all heat cannot be transferred into work. Means we require source and sink to transfer the heat from high temperature, that is source, to the lower temperature, that is sink. So it tells that the heat cannot be transferred in the one source of energy. It requires sink. So heat cannot be converted into work. All heat cannot be converted into work as per the second law. According to the second law of thermodynamics, heat will be transferred from higher temperature to lower temperature and not vice versa. Means as per the second law, the heat is transferred from the higher temperature, source, to the sink at lower temperature, but not sink to source. Similarly, second law states that it is possible for energy transfer to proceed along a particular direction or not. Similarly, a cycle can occur if it satisfies the first law. A thermodynamic cycle will occur if it satisfies both the laws, first law and second law of thermodynamics. First law of thermodynamics is a quantitative statement, means it depends on the quantity statement, and second law is about the qualitative statement. Now, energy reservoirs. As we say that in the second law of thermodynamics, we require source and sink. So the source will be also called thermal reservoir, defined as the body having an infinite heat capacity, which is capable of absorbing or rejecting the heat unlimited quantity of heat without suffering appreciable change in it. Thermodynamic coordinates all the processes are quasi-static. Similarly, the mechanical reservoir is a body, large body enclosed by an adiabatic impermeable wall, which is capable for storing the work as kinetic energy or potential energy. All processes are quasi-static. Now, heat engine. Heat engine is basically a device which working in a cycle and convert the heat energy formed into the work. So heat engine convert the heat energy into work. And there are seven types of heat engines, but they are categorized by the following. First one is they all receive heat at higher temperature source, that is oil furnace, nuclear reactor, and they convert the part of heat into work, and they reject the remaining waste heat to a low temperature sink. They operate in a cycle. Now, here you can see the heat engine. Heat engine takes the heat from a source, that is called furnace, to boil the water in a power plant. We can see the real example that the heat will be taken from the furnace to boil the water to convert it into steam. Means to boiling the water. Means here to increase the temperature of the water so that it convert to heat steam. So steam will be at high temperature and normal water. So boiling process occurs. This steam at high pressure and temperature strikes the turbine, and after striking the turbine, there is some heat rejection, and the temperature and pressure of the steam down. Then this down lower temperature of temperature comes to the condenser, which further lowers the temperature and pressure of the steam. Then it converts into the water. Means that steam temperature decreases and pressure decreases, so that it comes to the water state. This water having some heat as a feed water get extracted from the pump. Then this hot heat water is feed water comes to the boiler to increase the efficiency of the power plant. So this cycle continues in a power plant. Water from the pump extracted through the pump into the boiler, then boiler to turbine, which lowers the steam temperature pressure. Then this cycle continues the power plant. Now, refrigerator. Refrigerator is in a nature we can see that the heat is naturally the transfer from high temperature to lower temperature, but in the refrigerator process the heat cannot be transferred, but it is a special device which transfer the heat from low temperature in a high heat region. So here the example that the high heat the warm heat from the warm air from the room affect to temperature and high temperature pressure, then it goes to the high temperature and goes to the compressor, which increases the temperature and pressure of the working fluid and the refrigerant. This working fluid refrigerant go to the condenser, which decreases the temperature while maintaining the pressure. This higher pressure low temperature working fluid went to the expansor valve, so that here the temperature and pressure decreases and this process continues to give the cooling effect as per our design requirement. So now we end our session. Thank you for listening and maintaining peace environment for listening this session. Thank you.